Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 11 to 15 of the June 2015 Geometry Common Core Regents examination. All right, let's take a look at problem 11. It says, in the diagram of triangle ADC below, EB is parallel to DC. AE is 9, ED is 5, and AB is 9.2 as indicated here. Question, what is the length of AC to the nearest tenth? Now, you want to note that in this problem, we're not asked to find BC, we're asked to find the entire length AC. All right, that's a common mistake students make. They do not solve the problem completely, but they stop halfway, okay? We're looking for that entire length. In order to find AC, we need to find this missing side right here. Let's call that X, okay? All right, a quick reminder. When you're, according to the side splitter theorem, a theorem we're going to be using for this problem, if a line is parallel to a side of a triangle and intersects the other two sides, as we can see here, EB is parallel to this side DC, so this is parallel to that, and it intersects the other two sides. These two sides are divided proportionally. Okay, that is the side splitter theorem. That is what we're going to use for this problem. Steps. We're going to write down the side splitter theorem. Then we're going to label this triangle and apply the theorem to this triangle. Then we're going to solve for the unknown x. Now that is not the final answer, okay? After finding x, we'll find AC by adding it to 9.2. All right, so let's go ahead and get started. So the side splitter theorem, let's just write it again, even though we have it here for your reference. Just sketch a triangle. And this side is parallel to this side. This is A, B, C, D. According to the side splitter theorem, A over B is equal to C over D. All right, so let's label our triangle accordingly. So we can call this side A, B, C is 9.2, and D is X. I just followed this format over here, pardon my terrible sketch. Okay, so let's write down all the labels we just did. So A is 9, B is 5, C is, I think is 9.2. Let me see. Yeah, C is 9.2, and D is our unknown. Now, if we apply this side splitter theorem to this triangle, A is going to become 9 over B is 5 equals C, which is 9.2 over D, which is X. So we're done with step 1 and 2. Now we're going to solve this resulting statement. This ratio, we're going to solve it algebraically. Okay? Now, one thing we can do, we can either reciprocate both sides of the equation or multiply by x. All right? So let me go ahead and multiply both sides by x. I don't want x in the denominator. So if I do that, this x divides out. So this becomes 9 over 5x equals 9.2. Now, how do I get x by itself? Think back to Algebra 1. How do you get x by itself? You want to eliminate this coefficient by multiplying by its reciprocal, and that is 5 over 9. All right, so multiply both sides by 5 over 9. This divides out nicely, and then you have x equals 9.2 times 5 divided by 9. Let's use our calculator here to evaluate that product. So we have 9.2 times 5 divided by 9, and we get 5.11. So x is approximately 5.11. Let's go ahead and write that down. That's approximately 5.11. Repeating. Let's just put it 1, 1. Okay, so if you notice, we have option 1. Is this our answer? Is our answer option 1? The answer is no. This is a very good trap. Okay? Why not? Why isn't it 5.1? Well, all we just found is BC. This is 5.1. Did the question ask us to find BC? No, the question asks us to find AC. All right, so be careful about problems like this where a sub-answer is introduced to trap students who do not complete the problem. All right, so watch out for that. Now, to find AC, we'll simply combine AB and BC. All right, so AC is equal to AB plus BC using the segment addition postulate. So AB is 9.2 plus BC, which is 5.11. Well, it repeats forever. So let's see, 9.2 plus 5.1. If you add this together, this is an approximation, okay? It's going to be 14.31, and then the 1 repeats. Now, if you round this to the nearest tenth, we're rounding it to 3, it's going to be 14.3 since 1 is less than 5. Our answer for number 11 is option number 3. All right, let's take a look at this problem right here. It says, in scaling triangle ABC, shown in the diagram below, measure of angle C is 90 degrees. Question, what equation is always true? So we have 4 trig equations here. Now, a quick tip that we're going to use to solve this problem is that the sine of an angle is equal to the cosine of the complement of that angle. Okay? So remember what complementary angles are. Complementary angles add up to 90 degrees. Steps are as follows. First, we're going to determine if the angles under consideration are complementary. In other words, do you see all the options here? A, B, A, C. Which ones add up to 90 degrees? Then we're going to use this tip to set up equations relating the sines and cosines of complementary angles. And then we'll see which option matches the setup that we have. Okay? So if you take a look at this triangle right here, we know that A plus B is equal to 90 degrees. Well, how do we know that? Okay, let's go ahead and show you how that is the case. What is the sum of the angles in a triangle? It's 180 degrees, right? But we know that angle C is 90 degrees, so we have A plus B plus 90 degrees is equal to 180. So if we subtract subtract 90 from both sides, you find out that A plus B, angle A plus angle B is equal to 90 degrees. So what does that mean? A and B are complementary, or they're complements of each other. So what does that mean? Well, look at this tip right here. If you have two complementary angles, two angles that add up to 90 degrees, the sine of one is equal to the cosine of the other. Okay, so using the tip, we can conclude that the sine of A is equal to the cosine of B, and the sine of angle B is equal to the cosine of angle A. All right, this is an identity you'll be learning when you take trigonometry in the future. So let's just keep it simple and use this format. All right, so let's see which sine A equals cosine B. Oh, we have a match. Option number 4. That's your correct answer. All right, let's take a look at number 13. It reads, quadrilateral ABCD has diagonals AC and BD. Which information is not sufficient to prove that ABCD is a parallelogram? So we're looking for which of them is not sufficient, okay? Be careful about that. Now, something to note, actually 3 things to note, is that any of the following conditions is sufficient to prove that a quadrilateral is a parallelogram. Condition 1, that diagonals bisect each other. So if you have a quadrilateral and the diagonals bisect each other, that quadrilateral is automatically a parallelogram. 2, if you have one pair of parallel and congruent sides, that quadrilateral is a parallelogram. And lastly, if opposite sides are congruent in a quadrilateral, that quadrilateral is a parallelogram. Okay, so if any of these statements matches any of these ones, it is sufficient. So we're looking for which of these four does not match any of these conditions. Okay, so steps, we're going to sketch the quadrilateral, apply the following statements, these statements 1 to 4 to the sketched situation, and then see which of them is not a match, and that will be the answer. All right, so let's go ahead and I'm just going to sketch a quadrilateral right here. And then the reason why we're sketching this quadrilateral is just basically to give ourselves a visual as to what the statements are talking about. Okay, so we have quadrilateral A, B, C, well, let's be careful. A, B, C, D, because this C doesn't go here because AC is a diagonal, okay? So let's sketch in the diagonals. Diagonals are A, let's do that again. Diagonals are AC and BD. Okay, now, first statement, AC and BD bisect each other. What is that saying? If AC and BD bisect each other, it's just saying that diagonals bisect each other. Is that a condition here? Certainly is. It matches statement 1. This is sufficient to conclude that this is a parallelogram. Option 2, AB is congruent to CD. So AB is congruent to CD and BC is congruent to AD. What is that telling us? It's telling us that opposite sides are what? Opposite sides are congruent. Is that sufficient to conclude that a quadrilateral is a parallelogram? Certainly, because look at condition 3. Opposite sides are congruent. That's enough to conclude that this is a parallelogram. So that's sufficient. AB is congruent to CD. So opposite sides congruent. One pair of opposite sides, and then AB is parallel to CD. So you have one pair of opposite and parallel sides. If you have one pair of opposite, this is opposite and parallel sides, that is sufficient. Look at statement 2 to conclude that this is a parallelogram. Now, by method of elimination, our answer should be 4. Well, let's just read it though, see what it says. AB is congruent to CD, so one pair of opposite sides. BC is parallel to AD. One pair of opposite sides and one pair of parallel sides. It doesn't say that the opposite sides are parallel. It says the other side is parallel. Now that is not a parallelogram. Okay? Now, can you think of an example that fits this description? A quadrilateral with one pair of parallel sides and one pair of congruent sides that are not opposite, and is not a parallelogram. Can you think of that? Well, a good example is an isosceles trapezoid. Okay, let me sketch it for you just to help you see what we're talking about. So consider this situation right here. Let's see, 1, 2, 3, 4. Okay, so we have this parallelogram. No, we have this quadrilateral. Now you notice this is A, B, C, D. AB is parallel to BC. Okay, and AD is congruent to BC. Question is this a parallelogram? The answer is no, it's not a parallelogram because AD is not parallel to BC, but it fits the description of having one pair of parallel sides and one pair of congruent sides. If they are not the same pair of sides, then is not sufficient to conclude that the quadrilateral is a parallelogram. Okay, so keep that in mind. All right, let's take a look at problem 14. It reads the equation of a circle is x squared plus y squared plus 6y equals 7. This is known as the general form of the equation of a circle, okay? Question, what are the coordinates of the center and the length of the radius of the circle? Now, a quick reminder is that in center radius form, the constant on the right side of the equal sign is the square of the radius. That is a big mistake many students make. They forget that it's actually a square, so they forget to take the square root when determining the radius, all right? So keep that in mind. Now, one thing to note is that in order to determine the center of a circle, you must take the opposite of h and k in the center radius form of the equation of a circle. Okay, so don't forget to take the opposite. The steps we're going to use for this problem are as follows. We're going to write the given equation in center radius form by completing the square where applicable. Then we're going to write down the center radius form of the equation of a circle. Now we're going to use these two equations from 1 and 2 to find our center and radius. Okay, so let's go ahead and work on converting this equation from general form to a center radius form. So x squared plus y squared plus 6y equals 7. So first step is to express the x's and the y's as perfect squares, okay? So x is already a perfect square, so I can write this as x minus 0 quantity square. Y is not, so we have y squared plus 6y. Now, in order to make this a perfect square trinomial, I have to add a term that makes this a perfect square trinomial, okay? Now, if you add a term to the left side of the equation, in order to preserve equality and not change the problem, you have to add the same amount of that number to the right side, okay? So what number can I add here to make this a perfect square trinomial? This is the completing the square algorithm you learned in Algebra 1. You just simply add b over 2 square. Okay? All right, so in this problem, b is the coefficient of y. All right, because this is the y situation, b is the coefficient of y. So b for the y is 6. Now what do we do with that? Divided by 2, which is 3, and then we'll square it. b over 2 squared is 9. So I have to insert a 9 here and a 9 here. Now let's freeze for a second. What have we just done in this y situation here? What kind of trinomial is this? This is a perfect square trinomial, okay? The nice thing about perfect square trinomials is they can be expressed as the square of a binomial. How do we do that? We can factor, or we can use the following trick. We take the square root of the first and the last term, bring down the middle sign. That yields y plus 3 quantity square. Okay, so this algorithm is known as completing the square. Bring down the plus, and we have x minus 0 squared equals 9 plus 7 is 16. So what do we have here? This is the center radius form of the equation of a circle. Okay, this was the first one is a general form. Let me go ahead and write it for you. This is a general form, okay? General. And this one that we just created is the center radius form. Why is it called the center radius form? Well, because it easily helps us determine the center and radius. Now we're done with step 1. Step 2, we're going to write down the general center radius form of the equation of a circle. Okay, so that one is x minus h squared plus y minus k squared equals r squared. Okay, don't forget this equation is very important. Now, the center is hk, all right, and the radius is r. So in this equation, we can clearly see that h is 0 and k, you have to take the opposite, is negative 3. All right, so our center is going to be 0, h is 0, and k is, you do the opposite of 3, -3. So there goes our center. For r, we have to do some work. We can see that r squared is 16. Don't forget, this is the square of the radius. So to get r, we have to take the square root of both sides. We don't have to introduce plus or minus here because radii are positive, okay? So the radius is 3, okay? So r equals 3. I'm sorry, 4. Okay, so the radius is 4. All right, so let's look at our options right here. Let's write it down. Center is 0, -3, and the radius is 4. Answer to number 14 is option number 2. All right, let's take a look at problem number 15. It reads triangle ABC and DEF are drawn below. If AB is equal to 9, BC is equal to 15, DE is equal to 6, and EF is equal to 10, and angle B is congruent to angle E, which statement is true? Okay, let's populate the measures I'm given here. AB is 9, BC is 15, DE is 6, EF is 10, and then angle B is congruent to angle E. So the question is, which of the statements is true? Now, one thing to note is that the SAS similarity theorem allows you to conclude similarity if two corresponding sides are proportional and the included angle, that is the angle between the two sides, are congruent. Okay? All right, so these are the steps we're going to be using to solve this problem. First of all, we're going to determine the relationship between corresponding sides. Are they congruent or proportional? Then we're going to determine if the angle provided is included. We can clearly see that they are. And lastly, we'll arrive at our conclusion using the correct similarity postulate or theorem. Okay, so let's list our corresponding sides first. What are our corresponding sides? Our corresponding, let me just use shorthand here, corresponding sides. This is a scaling triangle, okay? So we're going to pair them using the by order of magnitude. So the smallest side in triangle ABC is side AB. So side AB, and in this in a smaller triangle, DE, okay? Side AB and DE are corresponding sides. Now, the second to the smallest side in ABC is BC, and then if you look at a smaller triangle, the second to the smallest side after DE is EF. Okay, so BC corresponds to EF. And then lastly, can you see the last pair of corresponding sides? In this triangle here, we have AC, and then the longest side here is DF. Okay, there goes our pair of corresponding sides. Now the question is, are they congruent or are they proportional? All right, so let's look at AB and DE first. AB is 9, DE is 6. Are they the same? No. So we can see that corresponding sides are not congruent. Okay, so since AB is equal to 9, which is not equal to the corresponding side on the other triangle, we can conclude that corresponding sides are not congruent. So let's write down our conclusion. Corresponding sides are not congruent. Corresponding sides are not congruent. Okay, so guess what that means? That means that the congruency postulate is out the door. Okay? If you have a pair of corresponding sides that are not congruent, then the two triangles are not congruent. All right? Okay, so we have that done. Now, how about proportionality? Are corresponding sides proportional? Well, to determine that, let's use the corresponding sides we have. We have AB, DE, BC, and EF. So we have these four. Are they proportional? Okay, so let's go ahead and see. The question is AB over DE, is it equal to, question mark, we don't know yet, is it equal to BC over EF? Is that the case? If so, then corresponding sides are in proportion. We just need a pair of corresponding sides to establish proportionality, okay? AB is 9, DE is 6, BC is 15, and EF is 10. Is this true? Is this a true statement? The right-hand side, we can now divide, we can reduce this by dividing by what? We can divide by 5 here, so 5 goes here 2, and 5 goes here 3. 3 over 2. And then over here we can divide by 3. 3 goes here 2, 3 goes here 3. 3 times. So what do we have? We have 3 over 2 is equal to 3 over 2. Proportional. Okay, so we have a proportionality statement here. So in this, for these two triangles, corresponding sides are what? Are proportional. Are proportional. Okay, corresponding sides are proportional. So that is needed for similarity. Okay, now corresponding sides are proportional. Are included angles congruent? Absolutely. Angle B is congruent to angle E. This is an included side angle, sorry, because it's between the two given proportional sides, and then this is an included angle also. Okay? Now, since corresponding sides are proportional and the included angle is congruent, we have the SAS similarity postulate. S, side, angle, side. Remember, S means corresponding sides are proportional, S and S, and the included angles for A are congruent. So since you're similar, the concluding statement we can write is that triangle ABC is similar to triangle DEF. All right, so there goes your answer. Let me just write down the concluding remark. Since corresponding sides are in proportion, and the included angles are congruent. What's the conclusion? The two triangles are similar, okay? Are similar. How do we know? By the S side, angle side similarity theorem. Similarity theorem. Okay? So we can clearly see that our answer is option number 3. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this tutorial beneficial to you, please give us a thumbs up. We appreciate your positive feedback. If you have any questions, include it in the comments section below, so we'll be glad to assist you in passing your upcoming geometry Regents exam. Do not forget to subscribe for updates to the remainder of this review series. More clips can be found on Mathgotserved.